This is the review packet for 4.4 to 4.6. So we are starting in 4.4, just solving equations that have a variable on both sides. First step is to eliminate one of the two. There's multiple, that means you've got to do some simplifying on one side, but when you have it down to just one single x term on either side of your equal sign or inequality, we're going to go after the smallest one. And again, the reason we do that is to keep things positive. When you get rid of the smaller of the two terms, you do end up with positive numbers. Now in this case, we're going to get rid of the -8 compared to the 24. But let's say you wanted to get rid of the 24, we do need to keep in mind that would clear out this entire side. And in that case, you'd have to put a 0 there. And sometimes it's better to just not even do that and just not follow the rule of getting rid of the smaller one, maybe get rid of the bigger one. But in this case, we are going to go ahead and add 8x to both sides here. So we are going to get 32x equals 16. Divide by 32. And then be careful, a lot of people want to divide the opposite way, 32 divided by 16 and get 2. But it's 16 divided by 32. So you're going to get 0.5, which you can leave as 0.5, or you can give 1/2. And we're not going to do a check for all of these, but let's run through one check and make sure that that half is correct. So 24 times 1/2 equals 16 minus 8 times 1/2. So when you multiply by half, it just takes half the number. So 24 times 1/2 is 12. This is 16 minus 8 times 1/2 is 4. And so you end up with 12 equals 12, and that works. And if you ran 2 through this, clearly it's not going to work. So if you did 32 divided by 16 on accident and got 2, 24 times 2 would give you 48. And then over here, 8 times 2 would give you 16. 16 minus 16 would give you 0. You'd have 48 equals 0, and you'd know something is wrong. So that's why those checks are so valuable. Okay, number 2, variable on both sides. No simplifying I can do on either side. So we're going to start attacking the smaller of the two, which is a 6r. So I'm going to minus it. So 13 minus 6r is 7r. I'm going to add 5. 14 equals 7r. Divide by 7. R equals 14 divided by 7, 2. Okay, number 3. I have more than 2 terms with an n on it. And so you look at your dividing line, and you simplify on the same side if you can. So the 8n plus the 5n is 13n minus 12. And now that I'm down to 2 terms, one on each side of the equation, with an n, the smaller of the two would be here. But in that case, if I go ahead and I minus n from both sides, I'm going to have to move stuff. I'm going to create extra steps because this side's going to get cleared out. So in this case, I'm going to go ahead and minus the 13n. And I'm going to get negative 12. And n minus 13 is negative 12n. So the only thing that comes out of not going after the smaller is I've created a negative coefficient. Really not that big a deal. Divide by negative 12. And n equals 1. Now when we get to inequalities, creating a negative coefficient means I'm going to have to flip my inequality. So in that case, sometimes it's better to stay away from it just so we don't make a silly mistake and forget to flip. But in an equation, I mean, it's just dealing with a negative number. Really not a big deal. All right, over here, got to simplify. So it's 9a plus 27. I'm going to minus the smaller of the two a's. So go ahead, and I've got 27 equals 21a. I'm going to divide by 21, and that's not going to give me a nice number. So I'm going to go ahead and leave it as a fraction. But when I look at 27 and 21, I can divide those by 3. I can simplify that. So let's say you did 27 divided by 21, and you get that nasty decimal. You go, okay, I don't want that. So you can plug in your fraction, 27, 21. It simplifies down to 9 over 7. And what they actually did, if you're doing this by hand, is dividing by 3. So you get 9 on top and 7 on the bottom. Okay, number 5, we're going to distribute on the left. So 12h plus 6 Distribute on the right, 2h plus 2. Minus the smaller of the two, which is 2. And we get 10h plus 6 equals 2. Now we're in good shape. So we're going to isolate that variable. So 10h equals negative 4. Divide by 10. And we're going to get 4 over 10. Now that's going to give me a nice decimal, so I can leave that. That's 0.4. So h equals negative 0.4. Or if you want to leave it as a fraction, 4 over 10 does reduce. Divide by 2. And you're going to get 2 over 5. But that's a nice decimal, so we can leave that there. All right, some fractions here on number 6. Remember that when you're multiplying and you've got a denominator that divides nicely with the whole number, you can go ahead and divide first. So you don't need your calculator here. So 2/3 times w is 2/3 w. When I multiply times the 9, I can do 9 divided by 3 first and then times by the 2. 9 divided by 3 is 3 times 2 is 6. So nice and easy there. Now, I've got fractions on both sides. You may look at those and not know which one's bigger. Now, when I just quickly look at these to compare, I know 4 is less than half of 9, because 4 times 2 is 8, so not all the way to 9. 2/3 is more than a half, so that's bigger. So I'm going to go ahead and minus the smaller one. But we've talked about you can minus the bigger one, you just get a negative. Now here I'd probably just grab my calculator just to save time. 2/3 minus 4/9, and that's 2/9. W plus 6 equals 1. I'm going to minus 6. Bring it over here. And to get rid of this now, I'm going to multiply by the reciprocal. So multiply by 9 over 2, or you can divide by 2/9. W is now by itself, and when I multiply here, think about this over 1, I'm going to get negative 45 on top and 2 on the bottom. If you wanted to bring that down, you could call it negative 22.5, but either one of those, perfectly fine. Okay, going on to some word problems here. Consumer A has a cell phone, monthly payments of $34.99. Consumer B, monthly payments a little bit higher, but offers him a $75 rebate when he signs off, meaning $75 will come off the price. So after 1 year, who will have paid more? So that means after 12 months. So you're paying, so let's see A. A is doing 12 times $34.99. So consumer A has paid $419.88. Consumer B is doing 12 times $39.99. That's $479.88, but they got a $75 rebate, so they get to take $75 off of that. And that comes out to $404.88. So after 1 year, who has paid more? Consumer A. How about after 2 years? So we're going to do this now again. So you can go ahead and you could just double these because it's just double the amount of months. Not this though, because that 75 is only going to come off once. So if I take 419.88, that was 1 year. So for 2 years, I'm going to have 839.76. For this one, take 479.88 times that by 2. That's going to be 959.76. But remember, you got to take $75 off just one time, not every year. That comes out to $884.76. So now, who's paying more after 2 years? That would be consumer B. So after how many months will they have paid the same? Okay, so we're going to have to write an equation here and set them equal to each other. So our equation here on the first one is going to be $34.99 times the number of months. We'll call that X. We want to know when does that equal the other one, which is $39.99. 99 times the number of months minus 75. So those are our two different cell phone companies. We're going to find out when are they equal to each other. So I'm going to go ahead. You could minus the smaller one, but you're going to create a 0. So I'm going to go ahead and minus this x. And I know that's $5 difference here. So negative $5 x equals negative 75. I'm going to divide both sides by 5 at that point, and x equals 15. Number 12. Got some populations here. 471,000 increasing by 11,000 per year. I'm going to jump to the end here. How long it will be until they have the same. So we're looking for equal here. The other one is 560,000 decreasing by 3,000 per year. So we want to know when are these two populations the same. We're going to solve this equation. I'm going to go ahead and add 3,000y to both sides. I chose that because negative 3,000 smaller than positive 11,000. So this becomes 14,000y. Okay, now I've got one term with a y, so I can start moving everything away from it. So I'm going to minus the 471. Clear it out, leaves me 14,000y, which I'll divide by in a second. So I'm going to subtract, and I get 89,000 divided now by 14,000. And we're not going to get a perfect number here. So 6.3571. They're asking us to the nearest tenth of a year. So that's this spot right here, 6.3, but the 5 calls it 6.4. So going to the back on 4.5. Same thing, just with an inequality now. So we're going to make sure we always get rid of the smaller of the two to keep things positive so we never have to flip our inequality. So I've got m on both sides. I'm going to get rid of the smaller, which is negative m. Add it. So it's 2m plus 6 greater than 2 minus 6. So 2m greater than negative 4. Divide by a positive 2. There's no flip. So m is greater than negative 2. Real quick, let's run our checks. Just one time here. First check, you're going to set equal. So plugging in for m, it's 2 plus 6 equals negative 2. Negative 2 plus 6. Negative 2 plus 2. So negative 2. Let's see. Oh, I see. I was like, this isn't going to work. Something's wrong. So it's negative m. I'm plugging in negative 2. So it's negative 2. So that actually becomes positive 2 plus 2. So that's 4. And negative 2 plus 6 is also 4. So that check works. Now we got to check our greater than. So we're going to go back and plug it in. We need a number greater than negative 2. So 0 would be good. So 0 plus 6. Use the greater than sign. 0 plus 2. So 6 is greater than 2. That's true. All right, so remember for your checks, you plug in this number, your boundary point, with an equal sign, make sure it comes out equal, and then you choose a number in the solution set, use the greater than or less than sign, and make sure that comes out true. All right, number 2. Smaller variable is the 2, so I'm going to subtract it, keep things positive. Won't have to flip this inequality. So 4p is less than or equal to 13, divide by 4. P is less than or equal to 13 over 4. We'll leave it just like that. If you divide and get a decimal, that's fine too. That comes out to a nice decimal. All right, we're going to distribute here. 0.5 is like a half, so negative 3 times a half. Negative 6 times a half is negative 3. And 6 times 2.5 is going to be 15, so this is a negative 15. plus 3. I'm going to simplify this side before I even worry about everything else. This is going to become a negative 12. Negative 15 plus 3 is negative 12. Now, I don't want to get rid of this because it clears out this side, and it works out because negative 3 is smaller anyway. So I'm going to add the 3r to clear it out here, so I get negative 12 greater than or equal to r, and I am done. R is less than. All right, distributing here, negative 2a plus, negative times negative, 20. Distribute, 6a minus 12. A on both sides. Let's get rid of this one. So 20 is less than 8a minus 12. Add 12. It's 32. And divide by 8. All positives, no flipping. So keep a on the right, keep it open towards that. That's 4. Remember, if you want to rewrite that with a on this side, keep it open towards the a. These say the same thing. Okay, 5 through 8, we're going to solve them and then put our answer on the number line. So first, distribute 4q plus 12 greater than or equal to 10q. Minus the 4 from both sides. Okay, so 12 greater than 6a. You're going to divide by 6, or q, I should say, not a. 6's go away, so q, it's open. Nope. Keep it facing the same direction. We didn't do any negatives there, so q is less than 2. So if this is 0 and this is 2, it's an open circle, no equal sign. It says q is less than because it's closed towards the q, so the numbers less than are this way. There's no graphing on the quiz, so no stress there. All right, multiplying across here, negative 6t, positive 3, 3t plus 21. T on both sides, let's get rid of the negative 6 by adding 6. So I'm going to have 3 less than or equal to 9t plus 21 minus. I feel like I've done something wrong here. Nope, I'm good. So negative 18 less than or equal to 9t, divide by 9. Keep everything facing the same direction. We did not divide by a negative. So t is greater than, negative 2, because it's open towards the t. So if this is 0, this is negative 2. There's an equal sign, so it's going to be a closed circle. It's open towards the t that says greater than, so we're going this way. All right, 8n. 4 times 1.5. It's going to be negative 6. Distribute here. That's a 2n minus, and 2 times 1.5 is 3. And on both sides, we're going to minus the 2n. So that's going to give me a 6n minus 6, less than or equal to negative 3. Add the 6. So 6n is less than or equal to positive 3. Divide by 6. Read it from top to bottom. That's 3 divided by 6. It's a decimal. That's 0.5. That's 1/2. Less than or equal to 1/2. So let's count by halves. This will be 1/2. This will be 1. This will be 1.5. This will be 2. So on the 1/2, equals is there, so we have to fill it in. This says n is less than, so we're going this way. Okay, last one, distributing negative 10b minus 5. Distribute the negative, so it's negative b positive 3 minus 2. 3 minus 2 becomes a 1, so it's negative b plus 1. Okay, b on both sides. I'm going to get rid of the negative 10, so I'm adding 10b to both sides. So it's going to clear out. I have negative 5 greater than 9b plus 1 minus 1. Negative 6 greater than 9b, divide by 9. This is not going to be a nice decimal. It's going to be 0.6 repeated, which we should know is 2/3. But we can simplify, divide by 3. So it's negative 2/3. Keep everything facing the same way. B is less than. So if this is 0 and this is -1, negative 2/3 is going to be in here. It is an open circle. There's no equal sign. It's closed towards the B. That says less than. So we're going to shade the numbers less than that to the left. All right, then number 9, we're just going to fill in what happened. So we went from here to here. So clearly, if you were looking at this doesn't make sense, because I would add 6x, right? And that's what the answer key says. Add 6x to both sides. But I would get 11, right? So this is supposed to be a 15, clearly. 15 plus 6 would be 21, so it's a typo, just missing that there. All right, from here on now, I'm going to add 5 to both sides. From here to here, I'm dividing by 21. And then from here to here, all I've done is simplify the fraction. So I apologize, that's probably a confusing first step for most of you there until you saw this. Just a typo, should have been a 15. So when I add 6, I get 21. And last we're on 4-6, we're looking at problems where there's no solution or an infinite number of solutions. So number 1, distribute 20 times 0.2 is 4. So we're going to have a 20x on both sides. And we're going to eliminate it. When that happens, we're left with -6 equals -4. That's not true. You can put that symbol or no solution. Distributing 10x plus 5 times 0.5, that's half, which is 2.5. So I got a 10x on both sides. I will eliminate, leaving me -5 equals 2.5. Not true. There's no solution. Number 3, -2x. Take half, -1. -2x, +10. So I'm going to add 2x to clear it out on both sides. I get -1 equals +10. Again, no solution. Distribute here. 4x minus 16. Here we're going to get 3x plus 15. I'm going to minus 3x from both sides. So clearly, this is not one that's going to clear out. I'm going to end up with an x. And so I'm going to add 16. They're just trying to keep you on your toes. Get 31 and I'm done. It's a normal problem. They just mix that in to keep you honest, I guess. So here, 50x minus 125. Over here, you can get 40x plus 10 plus 10x. Simplify this side first. Put 40 and 10x together. That's 50x. So I'd have a 50x on both sides. I'm going to minus the 50x from both sides, and I'm left with -125 equals 10. Not true. No solution. Okay, number 6. Explain why there's no solutions. You can show your work. Simplify the right side. 7y plus 14. You're going to minus 7y from both sides. You get -1 equals 14. Showing your work is the same to me as explaining it in words. But if you were going to explain it, you would say you simplify the right side. You eliminate the 7y from both sides. You're left with -1 equals -14. Not a true statement, therefore there's no solution. All right, number 7, how about this one? Minus the 5x from both sides. We have an inequality now. We're left with 3 is less than negative 1. Is that true? Is 3 less than negative 1? Nope. That's no solution. Lots of no solutions on this page. How about this one? You get 2x on both sides. So we're going to clear that out. It says 3 is greater than negative 1. Is 3 greater than negative 1? Yes, it is. So this is all real numbers. And number 9. So she drives her car 19,000 the first year, but each year she ends up driving about 500 more miles than she drove the year before. So Eric drives his car about 23,000 per year, and he too drives 500 more miles each year than he did the year before. Write an expression for each person's total mileage. So if you really dive into this one, I don't think they did a good job designing this question. Because if we're looking for total mileage, they're saying 500 more than next year. So first year is 19,000, 500 more miles than she drove the year before. So the next would be 19,500. And if you look at their solution, this doesn't say that. This is 1 year later, she only drives 500 miles. So this would tell you in year 1, the first year after, what she drives, and then year 2. But this isn't the total mileage. So you can call it a typo or you can call it a mistake. So it's just a bad question. What they're trying to say is, here's your starting point and you're adding 500. Here's your other starting point and you're adding 500. Okay, so they want you to write expressions for those. So 19,000 plus 500y. This expression, the one they wanted you to get to, doesn't represent what they said. It says you drove 19,000 the first year and then you're adding another 500 per year. That's not what they said, but that's what they were getting at. So it's just a badly worded question. Based on the answer key, you can tell that's what they wanted. And they're setting up equations that both have plus 500y, and that's the key, because they want you to clear that out and then see what happens. And so Eric has 23,000, and he's adding 500 per year. And they want to know, when is his mileage lower? So first of all, let's talk about when they're equal. You would set them equal to each other like this. You would eliminate the 500y from both sides. Right, and you end up with 19,000 equals 23,000. There's no solution. That means they'll never be equal to each other. And they want to know, when is his lower? Well, according to these expressions, again, not the badly worded question, but according to these, you're starting with 19, he's starting with 23. You're both adding the same amount every year. So when will his be lower? And that would be never. So again, I apologize. This is just a badly worded question. But they're just trying to come up with some kind of word problem that shows you're canceling the variable on both sides. So it is what it is. Not great, but you get the idea.